Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azaim binti Muhammad. The matric card number is CF190075. I will be the first speaker for this presentation. So our group number is Group 6, which consists of 5 members. I will talk about the causes of the slope failure. First, rainfall. A non-stop or heavy rainfall will soften the soil and making the soil erosion worse. Second, soil erosion. This can be caused by natural, which are by rain or wind, and the other one is man-made slope. The last one is natural disaster. As an example, at Japan, there are a lot of slope failure after an earthquake. Why? Because the seismic activity reduces the soil shear strength and stiffness, so the soil can hold and become loose. So, we already know the causes. Now, there are a few types of slope failure. There are rotational failure, which is rotate. Second is translational failure, which is the movement of the soil. Third is compound failure, which is the combination of rotational and translational failure. And the last one is wedge failure. Our case study area is located at Bukit Antarabangsa, Ampang, Selangor, that have gone through a landslide tragedy at 6 December 2008. This tragedy resulted in fatalities and property losses with more than 20 residences crushed. This is caused by heavy rainfall, which elevated the soil saturation and plasticity qualities. In this slide, I also put the rainfall data at Bukit Antarabangsa in 2008, which is a quite high rainfall data.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhafiza binti Sukafli. My matric number CF-0169. In this project, I will explain about the literature review of soil stability analysis. The soil stability analysis has been intensively studied over the last decade, mostly utilizing the numerical approach, the table the integral equation or boundary element method. Such approach will devise using formula to demonstrate how the soil is impacted by the parameter of soil characteristic. Limit equilibrium method. According to Kara Matthew, 2014, because of its simplicity and accuracy, limit equilibrium analysis is now used in the majority of soil stability evaluation. This approach includes slicing the slope into small slices and using reliable equilibrium equations such as force or moment equilibrium. For method of slice, based on study by Mr. Surupar and Batakan, 2017, a number of alternatives have been proposed based on assumption about the force between the shear force and the considered equilibrium equation. The most common approach to extreme balance is cutting. This method divides the volume of soil into vertical sections. Several approaches are used. This difference can lead to different outcomes, but factor of safety due to different assumptions and interflow boundary environment. For the method Swedish slit circle method, it is a method assumes zero friction angle with respect to the ground or stone. That is, when the friction angle is set to zero, the effective stress term is zero, which equates shear strength with a specific soil adhesion parameter. The Swedish sliding circular method assumes circular crack boundary and use circular geometry and safety to investigate stress and strength parameter. The moment created by the internal thrust of the soil is opposite to the moment created by the force that resists the collapse of the slope. If the resistance exceeds the driving force, the ramp is considered stable. By the study of Piner 2007, soil stability analysis using finite element analysis was performed several times in the same study. The finite element method combined with the more quantum method is valuable for determining the factor of safety of the inclined plane. The finite detail technique is the primary technique for soil balance evaluation. It is much more accurate and adaptable, especially since it requires far fewer prior assumptions about the fracture structure. In specimens with finite detail, what failure occurs naturally in the area where shear occurs. Electricity of the soil is inadequate to resist the shear stress. By the study of TV, Griffith and Lane 2001. Choosing an effective slope stabilization method necessitates a detailed study of the current slope condition as well as an assessment of the mechanism of slope instability. There are several ways to stabilize the slope. The embankment overhaul approach includes change to the embankment shape, drainage channel, retaining wall structure, and internal embankment reinforcement. In this project, I will explain about the technique of slope stability remediation, such as geometrical method, drainage method, and the retaining structure method. For the geometrical method, according to N. Nisa Azani and the others, 2011, the geometrical technique is the most commonly utilized strategy in the residential area. This procedure is typically easy and inexpensive. This approach doesn't require the high strain and it stabilizes the slope naturally in the running term. Changing the angle of inclination from steep to moderate can increase slope stability and usually maintain the angle as the crust is stowed into the soil. For drainage method, studied by Muhammad Noor, 2011, if a drainage system is installed, the risk of poor water pressure and subsurface saturation will be reduced. So drainage is typically used in containment structure in the form of hose and cut-off drainage. Surface runoff can release more water, especially during heavy rains. It can minimize the impact of large water absorption on slope. Based on the study of Robert D. Horst and Robert L. Huster in the retaining structure method, decline stability is usually described as a safety margin. If this factor of safety is strong enough, the slope is considered stable is safe. It is dangerous if it is less than 1. By the study of Amin, Pokasravin, and Bezet Kalentari 2011. This approach is relatively expensive but very adaptable. Because to its versatility in a constrained location, it is always the most widely used approach in the remedial operation, by study of the Danish Kazmi 2017. Thank you.
Hello, hi, and Assalamualaikum. My name is Mama Aiman bin Muhammad Nasir. My number is ECF 190228, and we are from Group 6. And today we'll make some explanation about the techniques to remedial the slope failure. So let's go for the next slide. And now we can see the condition in Bukit Antarabangsa. They have type 4 scope here of the factor or condition in Bukit Antarabangsa, which is the geological map, which is we can see that the failure area in the granite bedrock formation area, which is the acid intrusive rocks. For the factor of safety, for your information, based on the research, they have made some 25 borehole were drilled, and the result that we get is the right hand slope have factor of safety between 1.26 factor of safety FOC. And now we go into the status report on the causes of the failure, which is based on the data and based on the certain research, we can see that many pockets of loose material. And next, the potential rise in the groundwater table and poor water pressure. So next, for the upcoming events, if we cannot do anything about this area, the similar failure could be occur, and the slope strengthness works necessary to be complete quickly in this region. So we can see that in the figure, which show the resistivity test result conducted by GMG, which is Department of Mineral and Geoscience. So next, so now we go into the purpose method that we use, which is the first thing first is about deep calcium pie wall. So the specification is about 30 meter of deeps, diameter is 1.5 meter and space at 2 centimeter center. Okay. The deep calcium pie wall is functioning to intercept the failure plane in order to reduce the risk global instability and ensure the adequate socketing into the hard stratum will obtain. So next, the calcium wall is the aggregation support system made up of interlocking scan wall formed by vertically drilled holes. The shoring wall is made up from the series of soldier piles and the calcium fillers, with the piles stranded with the steel beams and filler left unreinforcement and filleted with the low strength concrete. 2 or 3 filler arrangement is used to space the hips and the pile that can be cantilevered or supporting using the wheelers, rackets, strut, tie brakes depending on the excavation depths requested. So now we go into the second method, not the second method, the other method that we use, which is soil nail with the T32 tendon and pressure gouting. So the soil nail and pressure gouting is functioning to overcome the localized failure in the existing slope at the site area. The pressure gouting was proposed to conjuncting the soil nail installation to ensure that the soil nail achieve the adequate raunch fraction, particularly in the slack pocket. According to GMG resistability test, this pocket can be found around 20% of the slope area. In order to strengthen the slope, this 20% of the slope area must be covered by grout. So this is a function of the pressure grout, which is they can cover up this 20% of losses. So next we go into the soil nailing is the construction technique that allow for the safety overstepping of the new or existing soil slope, and it is used to remedial unstable natural soil slope. Because of this area usually have the failure, so we use the soil nailing to make sure the unstable natural soil slope can be overcome. So this is the step by step to make the soil nailing, which is one is the drilling. Next we apply the steel, which is T32, and now we're going to apply the plate. And finally, we spraying the shotcrete. And this applying the plate, we also put on, in this insert the bar, we also put on the pressure grad to make sure the steel become more tighten than before. So this is the final result, which is this is our drawing, which is our sketch about this usage of these two technique, which is this is the soil nail and this is the hand duction with 30 meter long until reach the hard stratum. So this is the result of the data that we obtained. So that's all from me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.
My name is Muhammad Bin Jamil. My matric number is CF10193. Okay, I want to explain about the application of soil nail technique. Okay, this part show Rocktree Hydroelectric Power Station. It is about the history of the building. Firstly, it was erected in 1910 on the Virginia River. It has 20 meter high mud barrier obstruct the flow of the river. And lastly, it has 5 meter tall concrete retaining wall support the dam too. Okay, then we go into the Southern Tower, Sadomayas Castle. This is the history of the building. First, it is located on the Vistula River. Okay, then it is one of the Poland's oldest and most historical cities. The city is constructed on 7 hills spread by deep ravine and comprises roughly 120 old structure. And lastly, Sadomayas Castle is a top hill. Okay, we go into the advantage of the manufacture. Firstly, the wall needs to be fixed as quickly as possible to prevent the structure from collapse. Secondly, the retaining wall was repaired and strengthened without harming the dam's face using the earth nailing technique. And lastly, soil nailing return structure was produced using a technology developed by IBW PN. Then we go into the manufacturing method. Okay, firstly, the stone face was removed in the first stage of the repair, then doing the installation of a layer of light steel mesh on the wall. Then the nail hole were then drilled into the framework at a vertical and horizontal spacing of 1.3 meter. And lastly, the 16 mm diameter and 5 meter long high yield swing rod were then put and grounded into this borehole. Okay, then we go into the Southern Tower, Sadomayas Castle. This is the history of the building. First, it is located on the Vistula River. Okay, then it is one of the Poland's oldest and most historical cities. The city is constructed on 7 hills spread by deep ravine and comprises roughly 120 old structure. And lastly, Sadomayas Castle is a top hill. Okay, this is the advantage of the manufacture. Firstly, the Southern Tower is encircled by an 11 meter high medieval brick gravity walls. Secondly, the construct is surrounded on all sides by a curving 19th century retaining wall. And lastly, many large vertical features occur in the castle walls. Okay, for the lastly is manufacturing method. For the manufacturing, it shown by the picture that I show in this part for this slide. Okay.
So, these are the advantages of Kaizen wall. First, ground loss is eliminated by using a rigid shoring system. Second, ideal for shoring in close proximity to existing buildings and the other sensitive infrastructure. Third, it is possible to install it in poor soils and below the water table. And the last advantages is groundwater control has been improved and it is possible to design a cut-off wall to retain water and reduce project dewatering requirements. So, as the advantages stated, for the long-term stability, the Kaizen wall can be relied on. This is due to the fact that this type of wall is built deep in the soil and holds the soil very well. In terms of long-term stability, the soil nail can ensure that the slope stability is perfect. Furthermore, Kaizen walls reinforced with soil nails reduce the percentage of slope failure.
Okay, for the conclusion, slope stability difficulty have become the most serious hazard in Malaysia. As a result of the contrary natural terrain, several reasons lead to slope failure, although they are more likely to occur during specification season if driver methodological occurrence. All of the benefits in this case study are related to the soil quality. The location wall may be relied on the long-term stability. This is because the style of wall is placed deep in the ground and hold the dirt in place extremely efficiently. Location wall have several advantages, including the ability to be a rigid shoring method that maintains the strategic distance from ground loss and idealized for shoring close and existing structure and other dedicated from wood. The benefit of measuring the risk and determining the severity. which lead to the selection of appropriate mitigation strategy and a reduction in the number of landslide prevention choice available. So that's all from our group. Thank you.